Welcome to the Revit tutorial lesson 8. In this lesson, we will draw the staircase. It will divide into 3 parts. The first part is to practice the tool in Revit. The second part is to draw the staircase. Finally, we will try to model the staircase for ground floor. Let's start with drawing some simple staircase using the Architectural button. Under the Architectural tab, click the Stairs button. Draw the stair in an empty space. Similar to the wall, we just have to click the empty space and drag the stair out. And click again to confirm. Finally, click the OK to confirm. By default, you can see the stair railing will also be created. Let's create another stair. This time, we will separate the stair into 2 parts with landing. Create the first part of the stair by clicking the middle. Then, let's create the second part in opposite side. We can see that the landing is generated automatically. Also, the level of the stair is consistent. Now, let's create another one. There are different kinds of stairs, you can try them out by yourselves. But we will only use the first one in our lesson. Now, let's draw the third one. Remember to tick the automatic landing. It will help you to generate the landing. We can split the stair into different parts. Let's try again. This time, we'll select other type of stair. We will use the monolithic stair. Let's go to the top view. Even if they change the direction, the landing will also connect both flight of stairs. Moreover, you can see that this stair structure is different from the previous. Next, let's learn more about the stair structure. Firstly, we usually use step to describe the stair. Actually, we will call it run. In this picture, you can see that there are 1, 2, 3, 4. 4 run in total. Secondly, we will call the depth of every run as tread width or tread depth. Now, let's try to change the tread depth. This time, we will change the tread depth to 200. The warning window may pops up. It is because the Revit has some rule settings or calculations for the stairs. We can ignore this warning. Select the stair. Remember, we have to click the run to select the stairs component. If you click the stair railing, you are not selecting the stair itself. Change the tread depth again. Change it to 150. Ignore the warning again. Now, you can see how the tread depth affect the stair. We have created 5 stairs. All landing were created automatically. However, there are some situations that cannot form the landing. Let's create a new stair. create the first part. If we create the second part of the stair in a perpendicular way, it will warn you that the landing cannot be generated. Although the level of the second part stair is consistent with the first part, the landing part is too complicated to be generated. We can move the stair back to the right and click the landing button. Then click one part of the stair and click the another part of the stair. You can see that the landing can be generated. However, if the second part of the stair is too close to the first part, Revit cannot generate the landing again. If we place the second part of the stair in the green area, then the landing usually can be generated. However, if we place the stairs in red area, Revit may not be able to create the landing for you. Besides the automatic landing generation, we can use other way to draw the landing. This time, we select the Sketch Landing button. Then, we can draw the landing by ourselves. The flexibility of Sketch Landing is higher. You can see that the design of the landing can be free-form. Just make sure that the landing is enclosed. Finally, click the Stairs Path button. This path is to let the Revit know the direction of the stair. Sometimes, the landing cannot connect back to the stairs. The relative top height of the first flight staircase is 2450. Therefore, we need to change the landing height to 2450. The hand railing can be generated, but the design and the details may not be satisfied. Before we draw the stairs in Revit, let's understand the knowledge of the staircase. Now, let's understand the staircase in our ambulance depot first. This is the part of the stair. There is an arrow inside the stair. The arrow indicates the staircase direction. Then, there is a word, up 28R. This means that the staircase is 28 steps going up. The last one is the lightning symbol. Given that the stair contains a lot of steps, therefore, the drawing won't show the complete stair details. When we see this symbol, it means that the stair is connecting another floor. If we want to draw this stair, we need to take references from both ground floor plan and first floor plan. Let's go to the first floor plan. First floor contain the staircase from ground floor. Also, there is another staircase connecting the roof floor. On left-hand side, we have an arrow, with the words, D, N, 28R, which is indicating a staircase with 28 steps going down to ground floor. As we are looking at the first floor plan, the stair that we are looking at is connecting the first floor and ground floor. There is another staircase connecting first floor and the roof floor, which is the green area. it is a stair going up with 20 steps. Now, let's go to the roof floor plan. Firstly, we need to identify the stairs locations. Also, there is a landing. Therefore, this staircase contains more than one flight of stair. Finally, let's create the stair on ground according to the drawing. Now, let's draw the stair, on ground floor. Click the stair under the Architectural tab. We can see that the stair is 1100 mm width. Let's change the run width to 1100 mm. We don't have to create all 28 runs first. We can create the first part of the stair. And adjust the setting out of the stair. Here's how we count the run step. The step 0 is referring to the ground floor, it is not the first run of the stair. When we keep counting, we can count the 14th step. However, we need to count the last step, which is the landing. Therefore, this staircase has 15 steps run. Next, we will draw the second part of the stair. Now, we can see the whole stair. Then, use the dimension tool to help us. Under the Properties window, we can change the actual tread depth. Ignore the warning. Move the stair to adjust the setting out. Select the stair and click the Move button. The stair cannot connect to the first floor, because there is no opening on first floor. Let's go back to the floor plan. Select the stair, and click Edit Stair. Firstly, we want to change the distance between two flights. Change it to 150. Use the Dimension tool. Then check the distance between two flights. As we can see, the distance between them is 350. We need to change it to 150. Select the upper flight of stair. Then click the dimension to change. Change it to 150. And click OK. Go to the 3D view. Next, we are going to change the width of the stair. Click the Edit button. Use the Dimension tool. Dimension the width of the stair flight. If your staircase is not 1100 mm width, you need to edit the width of the stair flight by clicking it and drag the blue arrow. Next, we need to adjust the position of the stairs. Drag the cursor to select all the staircase components. Use the Move tool to move the staircase. Now, it changed to 250 mm from the grid line. Now, the staircase is overlapping the mass concrete fill. There is a concrete fill on ground floor. You can see that our staircase is overlapping that concrete fill. Let's change the base offset, so that the staircase will land on the concrete fill. Change the base offset to 150 mm, and press Enter. Now you can see that the staircase no longer overlapping the concrete fill. Go to the first floor plan. Next, we will create the opening for the staircase. Under the Architecture tab, there are different opening buttons. In this case, we use the shaft opening. Let's draw the rectangle opening. You can see an invisible box. This is the opening box. We can adjust the box size to control the opening. You can see that the opening box disappear. It is because the opening box cut through the floor slab. If we need to find the opening box, we need to move the cursor to there, and then press the Tab button. You may need to press more than once the Tab buttons. Here, you can select the opening box and edit the height of it. We can edit the boundary of the opening. We can always adjust and edit the shaft opening if needed. Ok, that's a good place to stop. Now, let's recap what we have done in this lesson. And after that I will leave you some exercises for you to practice before you proceed to the next lesson. In the first part, we created many stair as a practice. Now you are able to create different stair with landings. Also, we can split the stair into different parts. The landing could be generated automatically, or by sketch. We also learn the structure of a staircase, including rungs, landing, railing. In the second part, we saw the construction drawing, regarding the staircase part. Now, you should be able to identify the staircase in the drawing. Also, you can count the steps of the stair. You also need to read 2 floor plans to understand a staircase. By combining 2 drawings, you can fully understand the staircase. For the assignment, please use the same skills and create other staircase by yourself. Create a staircase according to the floor plans. The staircase can connect the ground floor and first floor with a suitable offset. The opening should be created on first floor according to the drawing.